So hello everyone, let's solve another leetcode problem. Recover binary search tree. So in this problem, we have given a binary tree, and in this binary tree, two nodes value are swapped, and we have to find these two value and swap it again. So in this first example, we have given a binary tree 1, 3, and 2, and these two values are swapped. So what we're gonna do is we have to again swap these two values in the original binary tree, and we don't have to return anything. So how we will going to solve this problem? Okay, to solve this problem, let's generate a bigger tree. So I will write a example of big tree. So wait a second. So this is the big tree. Okay, and if we use there are no two values are swapped over here. This is the perfect binary tree. Okay, so if we use depth first search, so what we're going to do is if we use depth first search, then we get output like 1 2 3 4 5 6 7. Okay, we will get output like this. So now let's swap the two values over here like in original problem. This is 5 and this is 3. Okay, there are two values are swapped. Now we have to again swap back these two values. So if I have swap this value, so our original now our binary tree looks like this: 1 2 5 4 3 6 and 7. Okay, our binary tree look like this. So how we will going to identify this two element 5 and 3? So to identify this element, we always know that previous element value is always greater than root element value. What this means is, if we will start from over here, this is our previous and this is our root. So previous value is always greater than root. Then we know, then we find a element. Like over here, if our previous is greater than root, then we will if we are first time getting that our previous is greater than root, then what we're going to do is first equal to previous and last equal to root. Okay, we are going to do like this, and when we second time this encounter this condition, then we only do like this, so our last become root. If second time when we go to this condition, so let's find out this in. So over here, this is the previous, this is the root. So over here, previous value is greater than root. So in our first variable, we get a 5. Okay, in last variable, we get a 4. Now we again go to and over here, this is our previous, this is our root. So again over here, previous value is greater than root. So in the last, now we again change the last value to 3. Let me change this like 3. Okay, and then we again go to traverse through this array, and we will find nothing in which we get in this condition. So we get our first and last node. Okay, so this is how we will going to solve this problem. So now at the end we will just swap these two values, first and last. So now let's write a code. So let's create a function def. Okay, so in this def function, what we am going to do is we will passing a root, and if we reach to the leaf node, then we will just simply return. Okay, and if I want to write only print the elements, like over here, if I want to print the elements, so what I am going to do is dfs root.left and print root.val, then again root.right. Okay, this is what I am going to do if I want to only print these elements. But no, I don't want to print this element. I want to find this two element previous and root. So for that, what I'm going to do is creating a variables previous and first and last. Okay, so we are using three variables, as you can see over first, last and previous. So I created an assigning none to all of this variable. Let me only type this. Okay, I have assigned none to everyone is this, and I'm just assigning non local, so I can use these values over here also, first and last. So by this statement, I can assign this first, previous, and last value. So what I am going to do is, if I visited the node, then I might mark as a previous. So previous equal to root. Okay, and over here we will write our condition. This condition, if previous is here, if previous has a value, because we assign none in first condition, we will getting this error is none type, none object has no next right or left variable, so that's why uh, so we will check previous dot val is greater than root dot val if this is the case, and if not root, not first. So by this statement we sure that we are encountering first time this condition, we are encountering this condition first time. So if not first, then our first become previous and last become root. Okay, so this is the statement. Now let's call this dfs root. Okay, let's run this code for any compilation error. Okay, we are getting a compilation error 1331. Even we are not changing these values too. Okay, we forget to swap these values. Okay, we forget to swap these values. So if first and last are, if first and last one has values, then we will just swap this first dot val and last dot val equal to last dot val and first dot val. So by using this, we swap the values of first and last. And now let's run this code again. Okay, sorry, I have to write below over here, because we over here we are not we are not running this function, that's why. So let's run it again. Okay, now we are getting the correct answer. Let's submit this code, checking for any compilation error. So as you can see over here, we have completed this solve this problem in big of n time complexity and big of 1 space complexity. We are not using any space. Obviously we are using space for this recursion, but that space is height of the tree. Okay, the space is height of the tree. So our space complexity become big O of h. Okay, thank you for watching this video.